In part 1, we took a look at the problem of creating a constant vacuum. We also took a look at some of the components we would need to solve the problem. In part 2, we put together the circuit on the breadboard and wrote a program to read the sensor, put it into the analog to digital converter, and output the result to the LCD. In this video, we'll make a couple of changes. First, this isn't really pressure. We're going to show inches of mercury. And we're going to convert this number, which is sort of meaningless to us, to a number that would be inches of mercury. So our new challenge is to take the ADC number that exists between 0 and 1023 and turn this number into a number that would be in inches of mercury. Our ADC output really isn't going to be 0 to 1023. Because we have a number that is actually at, we're going to be receiving 0.2 volts to 4.6 volts. And our voltage reference is 5 volts. So we have, at the bottom end, we have obviously 0.2 volts, from 0 to 2.2 volts. And at the top end, we have 4.6 minus 5 volts is 0.4 volts. So what range in our 0 to 1023 would be representing 0.2 volts and 0.4 volts. That way we can just figure out our range, our actual range in the ADC that would represent the limits of the pressure sensor. We can do this many ways. One way would be to take 1024, that's 0 to 1023 indexed by 0, and we can divide that by 5, which is 5 volts, which would equal 204.6. And then we can take that 204.6 and divide that by, there are, for 0.2, this is a single volt, so how many 0.2s exist in a single volt? That would be 5. So we can take this and divide this by 5, and that would be 40.92. We could also figure this out by taking 1024, and there are, how many 0.2s would be in 5 volts? And there would be 25 of them. That would be, to figure out this 25, you can just take 5 volts and divide it by 0.2. And then you'd have a number of 40.96. And this is different because this is actually supposed to be 46 because I made a mistake on this number. This should be 204.8, and then we'll get 40.96. Now we have the number that represents 0.2 volts in terms of the ADC. So our sensor isn't really going to be considering 40.96 volts on the bottom side. Then we'll have the actual range in between, and then 0.4 is 2 times 40.96, which is equal to 81.92. So let's figure out what our actual range is. So our range, I'm going to round these up. So our range is actually going to be 41 to 1023 minus 82. And this quantity equals 941. On the LCD, you notice that there was actually 945, 944, 943, somewhere in that range, because this number right here was sort of blurred. And that was because, remember, on our oscilloscope we were measuring 4.7, and that's probably why we got that number. So we'll probably use on the high end 945. I'd like to stick with what 0 may be on the pressure sensor. So now we need to figure out how to take 41 to 945 and convert this into inches of mercury. So what we need is essentially like a black box function. If we plug in the function 41, we will get a particular number in inches of mercury. And this would be the high number, or high vacuum number. And with the 945, we'll get 0 inches of mercury. So what is our high vacuum? According to the data sheet, the pressure sensor will go up to negative 115 kPa, kilopascals, or it'll go up to negative 16.7 psi. According to online conversion programs, the 115 kPa is actually equal to 33.96 or negative. We're just going to make an absolute value, so they're all going to be positive numbers. 33.96 inches of mercury. So when we plug in a 41 in the function, we should get 33.96. So what is the formula that we need to plug in these numbers to get these numbers to output? We'll use the slope-intercept formula. And the formula is y is equal to mx plus b. And the m is sort of the coefficient. It scales these numbers and puts them, makes them sort of the same size. And then the b offsets it. It moves the line. So let's see how to do this. And with this formula, you use the function, the number in the function, as the x-coordinate, and the number that it yields as the y-coordinate. So to determine the m value, m is equal to rise over run, or the delta y over delta x. This is difference in the y values and difference in the x values. And these are the x values, and these are the y values. So let's take the y values, 33.96, and it's minus 0, but that just equals 33.96. And then we have 41 minus 945. And this equals 33.96 over negative 904. And this is going to equal 0.037. I'm going to round it up to the fourth digit. So now we can plug in our 0.0376. This is what m equals into our formula. So our new formula is going to be y equals 0.0376 x plus b. Now we have to figure out what b is equal to. So we're going to plug in one of these. So we can take this as x and y, or this as x and y. I'm going to use the easier one. 945 and 0. So y is equal to 0, equal to 0.0376 times 945 plus b. This should be negative, actually. So we have 0 equals negative 35.532 plus b. We can take this to the other side, which would be positive 35.532 is equal to b. So now our formula is y is equal to 0, negative 0.0376 x plus 35.532. So now we can actually plug this formula into the program, where our x is going to be equal to the numbers between 41 and 945, and with this formula it'll yield the inches of mercury, and that will be y. And this formula will only work if we know that the output of the sensor is linear. If from the 0 inches of mercury to 33.96 is linear with respect to the voltage, then we know this will work. So let's go ahead and put this into our program and see what number we get. Okay, here's where we left off with the program. We set up the LCD and add a description on the LCD, which we're going to change anyway, vacuum. And we set up the ADC, the analog to digital converter, with interrupt, and we started the conversion, a single conversion. And here we have the interrupt vector routine. And what we're interested in is the 10-bit result, and that is essentially our x value. So all we need to do is go in here and add the formula to convert the ADC number into an inches of mercury number. In this video, I'm just going to show an integer number for the result, since I really don't need to show a decimal value. But later on, I will show how to do a floating point or a double precision number that does show decimal values on the LCD. So I'm going to start with just an integer, and our y value, which is the inches of mercury number. I'm just going to call it inches of mercury, and that will equal our our slope, which is negative 0.0376 times x, which is the 10-bit result, This is our X value. And we're going to add that to the B value. And the B value is 35.532. And now we want to take the inches of mercury. We'll copy it and put it into this line so it shows the inches of mercury. And we'll have to make sure it's in the right location. So let's count this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have to put it at the 14th location, 14th position. And this should be enough to get a number that is in inches of mercury onto the LCD. So let's make and program it. Let's see if I have any errors first. No errors, so I'm going to go ahead and program. So the controller has been programmed. We have our output showing vacuum mercury, and I could probably eliminate the HG for mercury because that's kind of confusing. It doesn't really tell you that's inches of mercury, but I'll do that later. And it's showing a 0 for our starting point, which is the 945 number. And I'm going to provide some suction and see if the numbers change. Okay, looks like it's successful. It was able to show inches of mercury with my suction, and I kind of know what that is because I've been doing this for a little bit and looking at it on a gauge. We'll do a confirmation of this on the actual system later on, but that is how to get the conversion from what we had in our ADC value and turning it into an inches of mercury number. If you are following along with these experiments or producing successful projects on your own, helped by these tutorials, please let me know using the Contact Us page on the newbiehack.com website. I would like to feature these on the website to benefit and motivate others to join this creative field. Thank you.